My name is David Cordy. I am a professor of geology at Edgewood College. So I'm joining you today from my home, as I'm sure many of you are. As we all know, with the recent COVID-19 outbreak, a lot of children have been forced to stay home from school. A lot of adults have been forced to stay home from work, which now means that a lot of adults that weren't previously involved heavily in their education of their children are now being forced to suddenly homeschool them. So we here at Edgewood know that this is a really big challenge, and not a lot of people are really comfortable with sharing specifically scientific information with their children simply because they don't know that much about it in the first place. So we hope that this video can at least show you just a little bit of information about some science and hopefully give you some ideas for some activities that you can do with your children at home to help them teach them some of these concepts of geology. So first off, I'm a geologist. What exactly is geology? So geology is the study of the earth. A lot of geologists study rocks and minerals, or sort of the materials of the earth, but not all geologists. Some geologists study things like rivers and groundwater. Others study the oceans and coastlines. Some study the atmosphere. Geologists pretty much study everything and anything that has to do with the inorganic natural world around us. So one major component, again not all, but one major component of geology is studying rocks and minerals. It's probably the first thing that a lot of people think of when it comes to geology. And rocks and minerals are really important to study because they give us a lot of information about just the material that we interact with on our daily lives. So for example, if you're building something, it's really important for people to understand the geology of the area which they're building. They need to know, is the ground underneath where they're building, is that going to be hard enough to support the building? Does it have any kind of fault lines in it that could potentially cause an earthquake? And what do we know about the chance of an earthquake happening in a location? If we know a little bit about the geology of the region, we can maybe plan for that earthquake, or we could potentially decide to build in a different location. We need to know, if we're building cities, like where are the best places to get access to water and which areas are potentially the providers of the cleanest water. So there's a lot of important geologic things we need to know in order to, build our cities and, conduct our daily lives. It's also important that if we're going to extract anything from the earth, we need to know a lot about that material if we're going to be able to use it most efficiently. So for example, if we're going to take a rock out of the earth and use it to build the outside of a building with, we need to know, is that rock going to be hard enough to do what we need it to do? Is it going to break down if it's suddenly exposed to water? Or are there any other kind of unusual properties we need to be aware of? These are all things that geologists need to be concerned about, and they need to know a lot about in order to make sure that we can do the types of things that we do all the time. So as I said before, rocks and minerals are a big component of geology. So let's talk a little bit just about minerals so we can hopefully have a better understanding of that, and hopefully it's something that you can then share with your children about what you now know about minerals. So first off, something that a lot of people typically aren't very comfortable with is just distinguishing between a rock and a mineral. A lot of times they're used sort of interchangeably, but they actually do have very different meanings in geology. So minerals, I'll give you a definition of those in just a second, but if you have a mineral, for example, quartz. Quartz is a really, really common mineral at the surface of the earth. It's actually the most common mineral at the surface of the earth. For example, sand is all little bits and pieces of quartz fragments, and there's a lot of sand in the world. So minerals are some substance, and they relate to rocks because if you get a whole bunch of different minerals together, then you actually form a rock. So a rock is sort of a combination of a lot of different minerals. So for example, I take this sample right here. So this is a granite. So it's something you might typically see in like a countertop or like a kitchen surface or something like that. And as you notice, as I kind of turned it around, there's a lot of different colors within it. So rocks, again, are just a bunch of minerals all combined together. Going back to this particular rock, you notice that there's some orange, you notice that there's some black, there's also some kind of light or clear colored material. So those are all different minerals. The orange is probably an example of one called potassium feldspar. It's one particular mineral that's also pretty common at the surface of the earth. The black might be something like a hornblende. The more kind of clear colors might be some of that quartz. That's that really common mineral that we see everywhere. So rocks are sort of a grouping of minerals, and the mineral is just kind of its own thing. Oops. So it's kind of analogous to if you take a whole bunch of these different elements. These minerals are made of a bunch of different elements that combine together to form this solid material. And analogous to that, if we take a whole bunch of minerals and combine them together, that's when we actually get a rock. So that's the big difference between rocks and minerals. Rocks are a bunch of minerals all combined, versus just a mineral is just one of those components within a rock. So what exactly is a mineral? So there's lots of different minerals in the world. So here's one example of one. So this is calcite. It's a really common mineral as well. So there's a handful of different minerals that we can find pretty commonly. Quartz and calcite are two of them. And notice that this wasn't cut or shaped in this manner. It's a pretty, it has very obvious edges. It has very smooth surface, and that's one way we can actually identify a mineral, is that it just has these really obvious features. There's this nice clean surface with really obvious angles between the different surfaces. So minerals have a very specific scientific definition. Two of the components that make up a mineral is that a mineral has to be naturally occurring. So it has to be something that's found in nature without the aid of humans. So if it's something that's made by people, for example, things that are made out of like plastic, that's probably not an example of a mineral. Minerals has to be naturally occurring. And all minerals are what we call crystalline solid, or even just more simply, they're basically solids. So there's no examples of gases or liquids that would be considered minerals. All minerals are solids. And specifically the crystalline part, it just means that the atoms that make up that mineral are formed in really regular patterns. So you can see in that one picture, you have all those atoms that are neatly stacked up next to each other in really regimented order. So that's really just different from a lot of other materials where other things might have kind of their elements sort of sporadically arranged. But minerals are always very regularly ordered, which gives some of them that really sort of characteristic like flat surface, because again, all those minerals are really nicely arranged. Now the exact arrangement can kind of shift from mineral to mineral, which is why this particular one has angles that are less than 90 degrees. Not all minerals have that same characteristic, but that's one indication that it is in fact a mineral, because it has those really nice smooth surfaces because of that crystalline solid material. So some other examples of minerals that sometimes people get confused with something completely different are gems. So what exactly is a gem? And essentially, there's not really a big distinction between gems and other minerals. Gems are just really fancy versions of minerals. So if we had a mineral and it looked really nice, and it looked nice enough that someone might want to take it and put it into a piece of jewelry, basically at that point we start saying it's a gem. It's not like a really well-defined example. Gems are just really nice examples of minerals. And we name gems based on the color that they show. So for example here, this is a piece of quartz, and this is specifically a piece of purple quartz, and you might know that as amethyst. So it is a quartz, but if it looks really nice and it gets to the point where people start using it in jewelry, we just simply start calling it a different name because it's used regularly for that purpose. So that also means that different gems can actually be the same mineral, since gems are just sort of the color that we see in that mineral. So for example, emerald and aquamarina are both the same mineral. They're a particular mineral called beryl, but if it's a really nice looking beryl that happens to be green, we call that an emerald. If it's a really nice looking beryl that happens to be that blue kind of watery sort of color, we call it aquamarina. Ruby and sapphire have the exact same relationship. They're both a mineral called corundum. So if it's a really nice looking red corundum, it's a ruby. If it's a really nice looking blue corundum, we call that a sapphire. So lots of different gems actually are sort of the same minerals, it's just depending on the color. And the color is all based on impurities. So if there's a particular chemical in that mineral that gives the mineral an overall greenish color, that impurity is what's actually causing it to be green. And if there's a different impurity, a different mineral, that might cause it to be a different color. So we normally think about geology as being something that's done in the field, but we actually can do geology to a limited extent right here in our home. So this could actually be an activity that you and your children can engage in, is trying to find some examples of minerals in your home. And remember that all minerals are naturally occurring and they are all solids. So just a handful of examples of some minerals you might be able to find in your home is I have here a pencil. So the actual material that we write with in a pencil, sometimes called lead, it's not actually lead, it's actually a mineral called graphite. So graphite is a black, it's kind of slippery, it's a really smooth and easy to break mineral. And it's really useful for putting in pencils. If we shave it down to those, the right diameter and encase it in wood, it can be really useful for as a writing utensil. Another example of a mineral that you might find in your home is I have here just a little bowl of salt. So salt is a specific mineral. It's called halite. And it just goes to show that not all minerals are extremely hard and long-lasting materials. So salt is an example of a really soft mineral, and it actually has a really unique characteristic that it tastes really good. So we put it in our food and we use it to season things with. Yet another example of a mineral you might be able to find in your house is talc. So talc is another very soft mineral. It's actually soft enough that if you were to sort of scratch it with your fingernail, you actually can start to break off flakes with it. It's also really slippery. And if anyone has any like foot powder or talcum powder, that actually is just ground up pieces of talc. So I have here an example of some foot powder. And if I actually look at the ingredients on the back of this can, the last ingredient is talc, TACL. And again, talc is not something that's made in a factory. It's actually a naturally occurring material that we mine, we grind it up, and we can use it as this talcum powder for various purposes. So I challenge you and your children to try and find some other examples and some other things that you might have laying around the house that are really good examples of some minerals. I already mentioned jewelry, so if there's any jewelry, those are probably examples of some sort of gem, which is again a fancy version of some kind of mineral. So the usefulness of those is not so much a practical use, but it's a really nice sort of aesthetic, a nice looking material. Some other examples of some minerals you might have around the house is if you have any ceramic dishes or bowls or something like that. We collect clay from the ground, and clay is an example of a mineral that then when you put it in a kiln, it actually hardens and becomes those stiff plates. So essentially plates and other dining ware might be examples of minerals if it's an actual naturally occurring material. If you have any potted plants around the house, there's probably some soil in those plants, and soil contains a large amount of the mineral called illite. Illite is really useful because it's really good at absorbing water and then slowly releasing it over time, much like a sponge, which is really good for plants because it lets it soak up rainwater and then it slowly redistributes it. So plants really like to have a lot of illite around because they can keep drinking that water that's slowly released back to them. So if you look around your house, I challenge you to try and find some naturally occurring crystalline solids, and you'll probably will see that there's probably a lot more minerals around your house than you might need. And that really just goes to show that we as humans have made use of lots of these naturally occurring materials. And that's all because of the work that geologists have done in studying the earth and trying to figure out what the best uses of some of these minerals mean. So, I wish you happy hunting, looking for minerals in your household, and we just hope that everyone stays safe out there.